Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter written in Swift, and we've done a few things on it. We spent last week, did a lot of work on the read eval print loop, our user interface, and I don't know. I bounced back to the functional side or to the implementation side of the interpreter. I don't know. I feel like I must be avoiding that user interface. I didn't have as much fun as I wanted last week on that. There's just so many little twiddly things you got to know and do. So, anyway, we're working on parentheses. So let's go to it. All right. Let's see. My mic seems to be on. That's good. All right. Let's see. So we left off parentheses and expressions, and I ran the tests just before we joined, and we left off with this failing test. So here we have 3 left parentheses, a floating point number, and only 1 right parenthesis. So it hits an end of file on the right parenthesis, and we'd like it to say missing a right parenthesis, but it actually says internal error should not happen. So we need to go make sure our parser handles the situation. Okay, so expects, okay, we can see right here it cannot happen. Let's see, the text we expected. I think we put that message in already, error missing a right parenthesis. So we have a test for it. It requires it. If it fails, it throws and comes here. Let's go to error messages. Well, is that over here? Yes. Missing right parenthesis. Okay, so we'll just use this message. I guess we were close. All right, and that should pass. Maybe. Yeah, I named the episode parentheses, but I didn't look too closely. Okay, missing is not equal to internal error should not happen. Oh, even worse. Okay, let's see what's going wrong here. So it's got the require. Let's see. Here's require. If token is not expected, throw a parse error and get next token. All right, and we believe we're catching that parse error. So at this point, we require a right parenthesis, and we're getting a token into file in our test because it sticks a token into file in there. Let's see where. Well, let's go ahead and just run this one test. I was worried we were going to finish in 2 minutes, but apparently that's not not the problem we'll have today. Now this, okay, so we're at the point. Do we have the input somewhere handy? Well, we know that we can see the token, I guess. Print token. Right parend. Okay, so if you recall our test case, we had 1 right parenthesis. We expect we're going to get here again on the next layer out. So we think we're 3 levels deep here. 1, 2, 3. Yeah, so that's good. All right, we'll continue. Okay, now let's see what token is. End of file. Okay. So we expect to throw the exception. We'll step over. Okay, we get the exception. We return error messages cannot happen. Oh, interesting. So, all right, let's go out. So right now we have the error message in our return value. token.leftParen. Okay, this is expression. So right now we've still got the error message coming out. Yeah, we're here. We actually need to check for that. So if the inner expression throws an error expression of some sort, we should just return that. Otherwise, we'll return the real one. Okay, well, I guess that case was good for catching that. Notice if we'd only done a one level deep, we might have missed it. We would have returned this right away, and that would have been fine. But I mean, this is the reason I do tests like that. 3 parentheses here, 1 here. I know I'm gonna hit some errors deeper down where I have to make sure I can take them back. Okay, so we can stop this. So if expression, well, what is this? Is error expression? How do I want to say that? I guess I'll try that one. Return expression. Okay. It's a little bit, I always question myself when I do an is or an as and have to cast things and stuff, but I think this is probably what we want. Yeah, I don't think there's a better way to do this with the try-catch we have. I mean, you could break them out. 2 separate do catches, but let's see if this works. Before we congratulate ourselves too much here. Turn off this breakpoint. Continue. Oh dear. Well, this shows you. Internal error should not happen. All right. Well, we'll put this back and we'll do it again. Okay. Hopefully this is just warming up to the week here. And okay, so we get a right parenthesis. We are back where we were the first time. This should be right parend. Yes. The expression is not an error expression. If we step over, we know we're going to return. Let's do that. Let's continue. So, interesting. So we parsed expression. Let's look at expression. Is a float. Now that seems wrong to me. Well, maybe it's not. The first one passed. So it does properly return a float. I guess I want to stop here too. All right, so let's go out the next. Oh, dear. What just happened there? All right, and let's parse. Leftparen calls expression. And that calls left parenthesized expression. Okay. Okay, we're about to call expression. Let's print token. Okay, so it's the left parenthesis. Right, so this is first time in. Okay, we'll continue. We should come back here. It should be another parenthesis. Okay, one more time. Okay, print the token, parenthesis. No, we're at the float. Okay. All right. So we're float, and the rest of our input is right parenthesis. Okay. We should call this and get back a float token. So let's step over and look at expr. Okay, that's the float that came back. And if we look at token, it should be the right parenthesis. Okay. So we got expression. We require a right parenthesis. Let's step over and step over. And now we're going to return that expression. Well, where does it go? It goes back to line 92. Parenthesized expression. And this is all in expression. Okay. Step over there. Exit that, and then we're back at 92. Okay. So we're back here. What's expression? Are we at the float still? Yep. Okay. And the token is a right parend. So we're going to require that. That should be fine. And, oh, are we, I didn't print token. COF now. Okay, so the right parenthesis. All right, so we got an error looking for the right parenthesis. Hopefully I'm not off my count here. We're going to return an error expression. Oh. Didn't I change that? Is it still my paste buffer? Yes. Okay. Let's turn this off, and just run it and see. Yeah, okay. Okay, if you spotted it before I did, you definitely get points. Next time, give me a little kick or something. All right, so yeah, if you keep returning the wrong value, you definitely will fail this test. All right, but at any rate, now we're getting the correct error message. We're also getting the right parse when it's not. So I think parentheses are working. All right, so let's, since it's been a while, let's diff this. Okay, so the parser, we added a case in expression. There should be more up here. Yeah. So we added up here, this rule is basically expression or term in the long run or factor or something, goes to int or float or uppercase name and now or left parenthesis. Okay, and we added added a little grammar expressing that. And then we added a case for the left parenthesis, which calls the parenthesized expression that we were in. And that's this. Okay. That should be it for this file. Error expression, we just added the new error message. And then the test should be the two tests for, both tests for the parentheses. Okay, so I'm good. Handle, let's say simple parenthesized expressions. Okay, and to do story parentheses, it's really the simplest case, but okay, new month, 2021, 0302, and here's the story, and this is simple parentheses only. Okay. So, like a lot of Elm, there seems to be a lot of overloading in the grammar that's not particularly easy to just kind of work around or something. I mean, I don't think they've made it like designed for easy parsing. Let's put it that way. And I think the parsing that they do, my understanding is the compiler is based on that parser combinator approach we started with here, which allows ambiguous grammars and things like that. And I'm guessing it kind of takes advantage of it. I'm finding it really. They've changed this. I'm finding it hard to understand all the cases I got to cover. Okay, so let me see if I can find an example where this goes weird. All right, so here's a parenthesis, square root of square of a plus square of b. Okay, we can handle, well, we don't do plus, but we would handle a simple expression like this or like this. But notice this argument, distance a comma b. So there's some sort of tuple-like object. I'm not sure where it comes. They don't have an example of calling distance, unfortunately. But seeing that makes me think they've got something like Swift's tuples. Yeah, here you go. 3, 4 equals 3, 4. So this bottom one is a tuple. And commas are not used in the function calls, so I don't think there's not that ambiguity. Maybe we should handle tuples. I don't know what you have if you just have one thing in parentheses. Is it a tuple? I don't know that it is. So the changes we would need, we'd want something, I guess, expressions in this case. Although look right above it, right? This thing in the let, this is two variables, and you can't have 3 plus 4 can't be in here. That tells me I've got to be a little sensitive about the location or the context of these parentheses. But I do think we can say if you have expressions separated by commas inside parentheses, that you're really getting a tuple back. I printed somebody's cheat sheet the other day. Luca Mug Elm cheat sheet. Let's see if we can find that. I meant to retweet it at least. I'm not sure if I did or not. Well, I think that other link was actually a more direct link. There it is. Yeah, that's a little tight, isn't it? Well, let's see if we can get it. I can kind of read that. Here's that example, the destructuring, and let's see, I don't see any tuples there. Add-ins, let A, B equal add-ins. So that makes me think we must be passing in a tuple as an argument. What else do we see with parentheses? Not much. The reason I wanted to get them in was so I could try and make the functions work. So if I have parentheses around a function, then I could call it with its arguments. Well, I'm not seeing much else that uses them, so maybe that's okay. Oh, in here, the imports. But again, I think we're going to be in a context where we've already seen import, so we can work with that. Same thing here. Module imports. Yeah, I think that'll be okay. I mean, we know we're exposing and then stuff. Same thing with the Elm destructuring on the let clause. Okay. That's lists. I thought there's destructuring on these things too somehow, but okay. Yeah, let's carry on. So, in the spirit of doing parentheses, let's keep this story going. So the way I use this is as a stack. So you kind of read down of what I think is going to happen next. So we're working on, if you get to the most recent story, parenthesis and expressions, that's what we're working on with this first task, tuples, or this next task, tuples. Then I thought maybe we'd do some function definitions, function calls, and then back to the REPL. I may move this REPL up. Like I said, I feel like I'm resisting it, so that tells me, there's going to be stuff that has to get done to hook that in. We've got an interface that's suitable for testing, but we haven't got an interface that's suitable for the REPL, the user interface calling us. And so I know we need to manage input, like new pieces of input either need to be a new my input or they need to be appended to it somehow. And we have a context. There's sort of a global context. It's going to have the predefined things like false and true, and it's going to have the previous definitions that we've made, and we want to evaluate something against them. All right, but anyway, tuples, this is left parent. Sometimes the help is not helpful. Expression, and then I've sometimes used this notation in grammars. It's basically 0 or more. Expressions followed by right parenthesis. And if we see one of these with commas, we need to return a tuple. If we see one with no commas, just one expression, we need to return that expression directly. Interesting. So that gives us some more to do here. All right. Okay, so we need a new test, tuple, and we'll just start with a simple case here. Hey, Code Wrangler, nice to see you. All right, so we just finished regular parentheses, and we're working on tuples. So if I have 9, I'm going to make it a little less deep so we can just see it happening. All right. And I don't know. I mean, in Swift, tuples can mix types, so that's kind of interesting. Oh, no thing there. Let's do that. Okay, so I'm saying if you see an expression with comma separated values that's in parentheses, that's a tuple. But if you only see one value, it's just the expression, and we're not even going to wrap it in anything. We just return the expression. This one, so we're talking about something new here. It's a tuple, which I guess will be a list of stuff. Well, I guess I could that and put it in here. Tuple, it's a list, integer elm number, and float value 1.0, Elm type dot float. Okay, let's pull this down. I don't know if you've ever run across a book Kent Beck had called Smalltalk Best Practice Patterns. And it's about formatting things for Smalltalk and thinking about code in Smalltalk. But one of his patterns is basically putting one argument per line and indenting them accordingly. And there's something nice to be said for that. Okay, so we got tuple, opening parenthesis, that closes the float, that closes that, and that, all inside another expression. Let's see. Cannot find tuple. Okay, that's a good thing. We just made it up. All right, so tuple, and I'm assuming it's going to have an array of values. All right. Cannot find tuple, so let's go up where we define float value. I don't even remember. You've got, yeah, everything's an expression at this point. Okay, so let's define a new tuple, a new file. Let's see, Swift file. Whoa, I'm not doing that. Next. Wow. Okay, I hit escape and it stops. Interesting. Try one more time, then I'm going to reboot the stupid Xcode. Oh. Okay. Cancel. I guess I could try it one more time this way. Well. New file. Switch file. Well, this is not good. Cancel. I'm gonna let me just, can I duplicate this? No. Okay. Save the files, sure. Okay. I don't know why it's opening here. Okay, we'll try this again. Can I type while it's doing this craziness? Huh. Okay. All right, so we have a class tuple. It's got to be an expression. That's going to give it some obligations. Well, maybe not. Well, we know we have to have an array of values, but I don't think we don't justify that yet with this stuff. So let's build. It'll tell us we don't have an initializer. Expression to Elm type. Okay. Init takes values of type expression, and right now does nothing. Oops. What else? Well, I'm going to make it unknown for now. That's clearly not right. I'm not sure what is right. I mean, it should be some product type, right? I mean, product type being like a record kind of thing. It's the tuple's kind of an anonymous record. So the type should be something like, in our case, our example case, it should be Elm integer, integer type cross float type. Well, this is going to drive us to do a lot of work, I think. We'll see what goes. Okay. Cannot convert argument to expected type. Argument Elm type. I think we worked around that. We're just trying to get a failing test right now. Pretty confident we can do that if we can compile. All right, so expression print missing a right parenthesis. Yeah, so print is not equal to error, missing a right parenthesis. I'm not sure where, we must have gotten this error here. Yeah, so we saw the comma and our primitive expression or parenthesis parser said, hey, I don't know what a comma is. I need a right parenthesis. All right, so that's actually a good sign. Expression.print, however, is not. We would like our tuple to print something tuple-like. Okay, so let's get expression. See what our obligations are here. Okay, so one is EQ and the other is as string. I don't know if we need to override that, but we need as string for sure, and we need EQ for our tests at least. Okay, so when are two tuples equal? That's a whole separate issue. We just need as string for now though, so let's just override. Let's provide one of these. Tuple. Okay, so this is an override. Internal func as string, and we want to return something like tuple with some stuff in it. Right now we don't know what the stuff is, so I'm just trying to get us moved a little forward. Okay. You might want to argue that I should be starting with a smaller byte, right? Because now we have to parse token. We have to pull these values and check them, and need to check equality on a tuple. So let's block this test for a moment. Let's get our parser parsing a comma. Okay, because it's a valid token we don't know about yet. Okay, so we got if. I'm looking for things that look like simple operator kind of things. Thought we had something. Oh, I really should be looking at the tokenizer, I guess. Our Lexer. Okay, we don't have a comma case, but this will be a single character token, so that's nice. Let's find our Lexer tests. Okay, left parenthesis, right parenthesis. Let's test comma. All right, and just like all the other single token ones, we'll make up a name token comma. That's going to complain. We'll go over here. We'll add comma. Okay, and this test should fail. Comma is not equal to unexpected character. Okay. All right, so we just need to add the case for comma, I think. Comma returns single character token with token dot comma. Now, I don't know if we, I guess we get EQ for free with these enums like that, so this should be okay. Right, okay. Good. So we'll check that in. Lexer knows how to find comma. All right. Next thing. Well, go back down. Oh, parser tests. Where's our parenthesized? I lost it. Nestable comment number. I guess I could just use this little trick. What? Parser tests. That's not parser tests. Okay. Another Xcode bug. Yay. That's more like it. Okay, we had our xtest tuple. Now we can read the comma. We skip spaces. That's fine. All right. I guess, the tuples really do need a type. I mean, all our expressions should have a type. Ugh. Do we want to go there first? I'm willing to make it be unknown for now. Okay, we got to modify this. And this is an Elm type, and we'll pass it through. So I'm pushing the Elm type unknown out, basically. Yeah. Yeah. All right. There's no member type. Okay, how's that? Oh, I didn't unexit. Well, that should build. Good. Okay. Now this should fail this test. Okay, so we got a better message that tuple is there, but we're still missing a right parenthesis. Okay. Let's see if we can do this. All right. So here, before the right parenthesis, I think we... Well, I think what we're going to have to do is our grammar is going to become expression, and then I've got my comma expression repeated 0 or more times. So when I see that 0 or more, that tells me I should be able to do a while loop on the token. Okay. And Let's get the parsing. All right. So because I see it requires a token, so I'm going to say while the token is token dot comma, I'm going to do something. Well, what am I going to do? I'm going to do the body. So I got to consume the token. Okay, so skip over the comma. And now I should get an expression. I don't know if I can even do this in this scope like this. Okay, I get an expression. Well, I'm not going to keep it for the moment. We're going to sneak up on our test. So I get the expression, and then when it finishes, it's got the next token ready, which should either be a comma or a parenthesis. And if it's not one of those, this message will say, I was expecting a parenthesis. I don't see it. What are we going to do about it? Okay. Let's see what we get. I think we will parse, but we will not return the right thing yet because we're not capturing anything. All right. Stop. Test tuple. All right. Tuple not equal to 999 number. Yeah. So we pulled out the first value in the parentheses and we just returned that value. That's what we've always done for parentheses, but we ate up the rest and including, we ate up the comma and the number. We would have kept eating commas and numbers as long as we needed to, and then stopped because we got something that wasn't a comma. It's a right parenthesis, and the parenthesis expression says, oh yeah, I want to write parenthesis. I'll consume that. You look good to me. I return the saved expression, the first term. Okay, so we're sneaking in. All right. I see by the clock, it's probably a good time for a break. So we'll take a couple minutes, just, quick drink or whatever. And we'll come back and capture the rest of the values. So I want to capture all the values in the list and start returning a tuple. So we'll come back and handle that. Thanks. See you in a couple minutes. Hey, welcome back. All right, let's tackle this. So we're going to need to save these values and sometimes return a single value and sometimes return a tuple. Okay. Let's see. Take a peek over here. Sorry. All right. Okay, so back to parser. All right, so here we explicitly threw it away, right? So no surprise that that's not quite kosher. Okay, so let's make this a var. Expressions equals expression. Okay, and then I want to do it that way. Let's go back. All right. Otherwise, I'm going to say var expressions equals exper. Okay, so that's going to be where I accumulate this stuff. Oh, we'll leave this a let. Okay. And we got the first one. Now let's get the next ones. I think I can reuse this variable, I hope. And I can say expressions dot append exper. Okay. So now when I get to the bottom and I'm ready to return exper, all right, I've got two cases. So let's see. So the cases are basically, do I have one expression or many expressions? So if expressions.count is 1, we're going to return expressions sub 0. Otherwise, we're going to return a tuple with expressions and elm type dot unknown. Okay, so we're still not handling the types correctly. We don't need this return anymore, but we are handling the case of one value. We just peel it back out and return it. It could be like an integer value or something like that. We temporarily accumulated it in an array, and now we're we're using that array for the tuple case, but not for that case. All right, I think that's all right. We can see we got an error case to handle around line 100, so we'll come back to that one. Okay, now I think that EQ is getting us. Tuple is not equal to tuple. Yeah. All right, let's create some tuple tests. We'll put this one on hold. Sorry, what's this blue line here? Okay, we'll put this on hold again. I don't know, is there an ignore thing or something for this? I just throw an X on it. Okay, and parser tests. All right, we want... Well, it looks like each of our types, like float value and stuff, gets its own tests, so we'll do something like that. Oh, this is weird. Oh, I'm in the wrong. Okay, so this is parser. Well, that's all these, yeah. Okay, so let's add a new file. We'll see if this goes any better. Okay. Well, this is Tuple tests. This is like some sort of weird test, isn't it? Okay. Oh, but I chose poorly. Okay, let's delete this. Try again. New file. I want to take one of these this time. We got John Reed's updated test case. I don't know what you call these, snippet. Yeah, how's that? Okay. Sorry about the headache-inducing flash. Test import Whelm, import XC test, good. XC test case, this should fail. But it should build. All right. So the case we wanted was just EQ. Where's our tuple and our expression? I guess I lost. Well, even float value would be fine. We need to override basically this kind of method. I'll put it in without committing to it. Okay, so no real behavior, just return false. We're going to call it with another expression. So the form for these EQ tests, all right, so it's we'll create a first value. Well, call it 1A, and then we'll make a tuple with an integer value of 3. And can I really not make a tuple of one item? That's interesting. And an integer value of 2. Okay. And I guess for now, elm type dot unknown. We'll come back to that. So the deal is you make two values that are equal, and then you make some values that are different. Okay, so value 2A is, well, let's start with an error expression. we just need any arbitrary expression. Doesn't have to be it doesn't have to be a particular type, just another expression type. Integer value 3 elm type dot number. Okay. So 2 integer values in the unknown type. Okay. I'll just be lazy. Okay. Definitely different. Okay. Value 2b equals, we'll make a tuple that is, let's give it the first value but not the second. Or let's give it a different value. Now I want to leave just a one argument one. I don't know if I can. I mean in Elm terms. So we'll make the second value the same as the other. And the type the same. So the types match. The values inside don't, and then let's go the other way. And maybe I should call these 2, 3, 4. Let's make this differ in the type. And I'll just pick one that I know is out there. And generic. Okay, so now the assertions. So we want to say that assert. I guess we're testing our EQ methods, so we will say value 1a dot EQ value 1b. We expect that to be true. And then assert equal value 1a and dot EQ value 2 true false. And I don't know, I tend to like these assert I tend to prefer asserting with the explicit values in this case, just to be kind of line it up so you can see the situations. It's almost like a truth table kind of thing. Okay, so I can see 1a versus 1b is true, 1 versus 2, 1 versus 3, 1 versus 4. All right, this test should fail. Okay, false not equal true. If you recall, we left everything returning false, so it was easy for these to pass. Okay, and where's tuple? Let's get it over by its test. Okay, so if the other type is tuple, then that's pretty good. Okay, and we have self dot. Well, now you know, we haven't even stored the values. Self dot type equals other dot type. Okay, that's coming from the parent. Okay, and to make this go, we got to save these values in here. So self dot values equals values, and values. Well, I guess it's gonna be let values of type array of expressions. Okay, that should go, and I believe it should pass now. I think there's an equality test on arrays. Okay, and let's break something just to make sure one of those falses flips. Okay. And we'll return true for a brief moment. Make some other ones fail. Okay, true not equal to false. Okay. Yeah, value 3 comes under the same case as value 1 versus value 2, or 1a versus 1b. Right, okay. I'm just kind of making sure it's easy to get these booleans a little bit flipped up and make them fail for the wrong reason. Okay, so now we have add equality test to tuple. Right, all right. So I think let's see our parser tests now. We're back to this one. But we had tuple not equal tuple before, so I think I was probably premature to check in. I would have liked to have had this in there too. This should pass now. Okay. Add test for tuple parsing. Okay. Successful case only. All right. So now we want to get those broken cases. So I'll borrow this one for a structure. So tuple gets error if right parenthesis is missing. So let's do this for that. Okay, so no right parenthesis. It should fail. We'll see if it does fail. No, why doesn't it not fail? Oh, yeah, so we parse it. We hit the line that says I'm looking for a right parenthesis, and we realize, nope, you don't have one. Okay, so that's good. I guess that's failing from, it gets that message from whatever happened before. So this line was always there, and if it's not done, it's not right. Okay, but I think we can have another case. And I don't know. I think gets an error if, let's say, comma is missing. I don't know. It's not an error at that point. Let's see what we get. There's no reason it has to be an error, because if we take out this comma, I don't think people leave out commas like that very much. Maybe they do when there's a new line or something, but I think the error it's going to get is still going to be the missing right parenthesis, because it's going to expect it here. You either have a comma or a parenthesis, or here. We got a 4. We don't know what to do with a 4. Now, if it were a function call, f of 4, we would rely on the inner parsing of expression to realize, like, oh, there's a function call. Don't do anything. So I think this might get an error. Missing right parenthesis. I don't know. I'm trying to. I think there's one more case. So let's see if this gets that error. Okay. Yeah, the other case is you've got the comma, but you don't have the goods on the expression. Okay, error if expression is missing after the comma. All right, so this one, we have a comma, and we didn't put the expression. I don't know what the expression is going to be. It is certainly not going to be this. Let's take something we know will fail. Okay, and run that. Now we're calling expression on right parenthesis. It should get an error. Okay, what error? Missing right parenthesis. Now that seems a little off to me. Okay, so we come in, we get our comma, we call expression, we append it. The error we get. See, I expect this same kind of thing. If you've gotten an error in the middle, then we want to return that error. Are we getting that error though? I don't know. We're not. I think if you went into expression with a right parenthesis, that thing's going to say no. There's a problem. Empty expression. Okay, which is an error. Is it an error? It's not really an error. Well, we may be detecting something real here. Okay, so let's make another test. This is really an expression test, and I don't know. This is getting long. What do we have here? This is Parser Tests. Well, if somebody comes in unknown custom value, yeah, let's try this. So test oh, the problem is, yeah, if we go into, we won't go into expression unless we know it's one of these things. Okay, so if you call expression, I don't know, this to me seems like it should be it should be an error expression. So if you call expression with something we don't know how to parse, I think it ought to say error expression. I expected either a number, a name, or a left parenthesis, something like that. Okay, so let's make that the default. Okay. Unknown character at start of expression is an error. Okay, so in this case, it's a check failed parse. No, we still won't get there. I mean, it won't happen here because you call parser, and it's before it decides to make you an expression, it's up here, and it gets an unexpected token. What do we have for a value down there? Tests. Okay, yeah, that's okay. This one. Gets an expression if the comma is missing. He's now getting error missing a right parent. No, he's getting arrow and lambda expression. I thought I put that here. I didn't put it anywhere else, did I? If statement, no, error. Parenthesized expression. Okay, so I'm sorry. I don't think I can make the test I want directly. But the error we should get... No, I'm sorry, something's going wrong. Oh, that probably belongs here. Okay, I couldn't figure out how come this one would get a lambda expression message. Yeah. Okay, so we're not getting that. We're getting missing. Oh, it's weird. They flip the arguments. Okay, we're getting error missing a right parenthesis, but that's what we actually have. So we're getting the wrong error. That's true. And I think what that means is we need. I don't think I can test it up there without digging into the parser, which I don't really want to do. I want to do it in the context like we're doing here, where it gets there and it doesn't find it. So this I would like to be it's like improper character at start of expression, unexpected character at start of expression. I think that's what we want. Okay, let's go to error messages. We'll add this in. Unexpected error character. So I'm trying to alphabetize a little bit. That equals we expected a number, a name, or a left parenthesis. Okay. Stacking myself up a little here. Let's get rid of this and this. Okay. So this should now fail for the right reason. I mean, it's not. It's going to have an empty expression, no error message, and only with the right parenthesis error. Okay. Missing a right parenthesis, but we have a right parenthesis, so that's not really the right error. All right. So I'm basically doing this same thing here. That. Okay. Now that still won't get us quite right. I think what we'll have is an empty expression, and it should still fall through, or it will still fall through, even though we don't want it to. And we get missing a right parenthesis still. Okay, so what we're getting back is this empty expression, which is not what it should be. I don't think. I'm hope it's not. Okay, so this I want to be an error expression. All right, and then error messages dot unexpected character. Now my fear is this might break some other test that was relying on the old behavior. My hope is everything's green. Okay. Nobody was relying on that. That's good. I don't know why I did that. Seems like a very bad habit. I should be putting, error messages to do or something to if I'm not willing to handle it. All right. But in any case, I think. Okay, a tuple with a right paren missing, a tuple with a comma missing. Let's put these in sort of order. Okay, you've got no comma, you've got a comma but no stuff, you've got comma stuff but no right parenthesis. Okay, I feel good about that. That should still pass because I just reordered. Okay. Support returning a tuple for an expression like 3, 4. All right. Now the type is wrong. Okay, so let's go into Elm type. A non-generic function. All right. This is a new thing. Okay. A tuples type, I think, should be. I don't know if I want to say product. Maybe I do. I mean, we're talking types, and that's sort of a good type term. But I'm imagining that there's a product type that takes two types and multiplies them. And multiplying types means you can have an element of the first type and an element of the second type. You can also have 3-level types. So do I need to be an array of these things? I don't know. If I think type multiplication should be commutative, right? So A cross parenthesis B cross C should be the same as A cross B parenthesized cross C. If it is commutative, I think I can just make it be the first type and a second type. And if you do ABC, I don't know. Maybe it's easier to do the array type because we have all these expressions that came back. Each one has a type. We could put them in a big array type thing. Okay, let's play with that idea. Okay, so I don't know if I'm being clear. Okay, so we handle the tuple, but we don't handle the tuple types. Okay, so if I have a Boolean, comma, Boolean, I've got 4 possibilities. If I have Boolean, 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 I have 8. So we are definitely multiplying these things. That's why they call them products. Maybe cross products isn't quite the right word. Okay. And if it's int times Boolean, it's got the number of possibilities for int times the number of possibilities for Boolean. Okay, but this can come down. Simple parentheses, or how about a single parenthesized, parenthesizing a single value produces that value. Parenthesizing a comma list of values produces a tuple. Yeah. Okay. Tuple types are products of types. Okay, this is getting deeper. Wow. So the other place, like that you see products of types, we can see an example, I think, in here. Where's his functions? Yeah, square in hypotenuse AB. Okay, that AB is a product of types. It's you give it a value for the first one and a value for the second one, and the number of possibilities is the product of them. If you said, what's the type of this function, it would say, well, I don't know if it knows from this plus that it's an integer or a number. It probably would say number cross number goes to number, I guess. Can we do this in our REPL? Let's give it a shot. Seems like we ought to run that at least once in a while, right? Square n equals n squared. Okay, type number to number. Good. Hypotenuse of AB. AB equals, I think I have to do that. Yep. Square root of square of A plus square of B. Okay, float goes to float. So, square root is a float. we'd have to look up square root, but I think this said number to number, so square A should be a square, a number. This should be a number. Oh, maybe square returns a float. That could be. Okay, because you could say into the 1.5, something like that. All right. So yeah, I mean, this looks like float goes to float goes to float. It's the first two are the input arguments. Float goes to float. And then last is the result value type. What does this mean for this? Well, let's try this. 3, 4. I hope I haven't been doing something that's not. Oh, interesting. Number 1. I don't know what that means. Number float. I mean, maybe the numbers are not comparable or something. Number 1, 2, 3. Okay, or number 2. All right. So where's that leave us? Those are. Oh, interesting. That's a tuple of types as well. And let's try a nested one. 1, 2, 3. Okay. Oh, so we do want a single value. We want an array of values for each of these, and they got their own little standards. Okay, so this is a maybe we should just call it a tuple type. A tuple type has the type. It has an array basically of types, but the type here is another tuple type, which is okay. Okay, so I think that gives us some direction on the types. What do we have for tests on types? Type tests. Okay. This may all just be kind of automatic. We may want to format to be different. All right. I think we'll come back and create a test on our new type. And once we have that new type working, we'll incorporate that into our tuple. And at that point, I think we have a valid tuple, which is a brand new type that we support. We support booleans, numbers, floats. Was there anything else? No arrays yet. Yeah, we just support those 3 for right now. So we'll add a 4th type, and this one's more of a composing type. It builds types from other types. All right, so we'll take 2 minutes. See you back in a couple. All right, welcome back. I didn't really check the clock, so I might be a touch early. But I had another idea as we were doing, as I was thinking about it. We have Boolean right now. You can define the type Boolean equals false or true. And you can define your own types like that. So I'm curious what type it comes up with for those. So if I do type, type foo equals user string. Okay, so that says you have a custom defined type foo, and user takes a string argument. Now Boolean is just false or true. There's no parameters on these things. These are more like Swift's complete enums where they allow parameters. I don't know the type. Oh. Can't find a foo. Okay, can't find. What's a user? Is a function string to foo. Okay, interesting. I didn't know if it was going to be one of these tuples or if it was going to be something else. I didn't quite expect a function. Interesting. Okay, so we'll have to start thinking of those that way. All right. So we said we were going to test a tuple type, I guess. So we'll make a test tuple type. And if the type is elm type.tuple, it's going to take an argument. Let's take elm type.number and elm type.float. Just so we're mixing them up. Has no member tuple. That's fine. We'll get there. I guess I want to make the equality is almost free. Maybe we'll just do that. Type 1A, 1B, and 2. Assert equal type 1A equals type 1B. We want this to be different, so make him float. Assert not equal type 2. Okay, so if I had these things, number float differs from float float. First one's equal, the second one's different, but I don't have that type yet. Okay, so if I add case tuple, types of array of elm type, right? Okay, I think that's just gonna work. Then here, well, case tuple. I think I can just do this. Return TBD. We don't handle that yet. Oops. Now this moves it up. Okay. Oh, hashable too, man. Wow. Okay. Now this, I don't know. This is types. Did it again. Okay. Has no member tuple. Let's capitalize this consistently. Okay. I think this equality test will pass right off the bat. So much for that. I guess I have to be consistent everywhere. All right. Oh, was it still complaining? No. Okay. Yeah, so that mostly comes for free. Let's get the format. Type format. And I think we saw parenthesis space, number, comma, space, blah, blah, blah. Okay. So we're going to assert equal type dot format should be equal to parenthesis space, number, comma, space, float, comma, parent. Okay, and this will fail. TBD. Okay. Let's see. Oops. Elm type. Now this is getting a little, it's a little complicated. So we need to get its values. Okay, and values is an array. So if we did, we got to go through the values dot. We're going to map each element to its type, to its formatted type. Yeah. Okay. And then dot, and then there's something that will. Oh, how do you joined? Yeah. Joined with comma space. Okay, and then we'll capture that. And well, how about inner types? And then we're going to return a left parenthesis, a space, and in here, inner types. Inner types. Okay. I think that's it. Apparently not. Okay. What do we get? Number float is not equal to number float. Oh. One of us. Wait. Oh, float is capitalized. Yes, that's correct. Float up here. Yeah, so float is determined to actually be float. Number means it could be integer, could be float. We don't have a case for integer yet. We'll get that when we get some operators in here. All right, but I think this should pass now. Wow, okay. I was afraid this would take us like 20 minutes or half an hour, but I think we're kind of there. Okay, so now the tuple types can format. That's good. All right. We're not creating it, so well, we add a tuple type. Added tuple to Elm types. And we can probably close this. But our parser tests are good case. This type should not be unknown. This type should be a tuple with elm type dot number. I don't know why it's not giving me, I guess it's not parentheses. Oh, it didn't capitalize that either. Number and elm type dot float. Okay, and parenthesis or bracket. See, this should be right. We should get whatever the inner types are, and the outer, or the elm type tuple should have the types of its inner values. Okay, so I think the test is good, but it's going to fail. It would almost have to, right? It was returning unknown or something before. Okay, tuple is not equal to tuple. Well, that tells us our tuple doesn't have a very good printer. Format string or whatever we called it. Let's get tuple. Let's fix that first. Okay, so this Well, we want to get those expressions in. So I think in general, I think we're going to kind of the same thing. We're going to take values dot map each expression well, there's a bit of an evaluation issue going on here, so I don't know. I guess this is our debugging string more than anything else. So we'll take those values, we'll map each expression to its string, and just like before, we're going to do joined separator, comma, space, and put the whole thing in here. Inner values, parenthesis. Okay. Let's see if we get a better error message. And it should be showing us the integer value or whatever those things are, that they're still values, they're not evaluated. Okay. Yeah, that's much nicer. 999 float number float is not equal to 991 number float. Okay. Yeah, because we don't put the type in there. Okay. But I think you can infer the type from this, so I'm okay with that. All right. And I think what that's going to require is one more bit of stuff, not here, but in the parser. We passed type unknown. We need to make a result type. So we'll take the expressions and we're going to map each one to its type. $0 type. Okay. And that's okay. So let inner tuple types, maybe just types, equal that. So given our list of arrays, our list of expressions, we get each one mapped to its type, and then we're going to return the type tuple with types. Okay. And I believe that should pass. Yeah. Wow. It's another one. We're hitting a fairly deep concept in how the typing and all that stuff works. So I hope it all made sense. But we have the tuple expression, which has the values like 3, 4, and each of those values has a type, but we want to be able to say there's a type independent of those values. And it's kind of this combination type, tuple type, elm-type.tuple. It may be confusing. I'm naming everything the same, but the tuple expression has a tuple type, and the tuple type knows the types of the inner expressions. We can, and we're formatting them like they're formatted over in the real Elm REPL. Okay, that's really good. Now, how somebody uses that, I guess where they use that. Let's go back here. I don't know if this is visible, but let A be equals add-in. So that sort of assumes, like this, they're coming in as a tuple. So we can pass in a tuple, and then we know that the types are number and float, and we can decide is number plus float legitimate? Yes, it is. Its type is float. And so the sum would be type float. So it definitely makes sense. We still have some, what do we have? We still have a few more places that are going to use parentheses, not in the sense of an expression, but in the sense of some other usage. Okay, so we had the imports, wherever those got off to. Yeah, so import exposing parenthesis dot dot. Okay. We also have parenthesis can wrap an operator. Yeah, a plus b is the same as parenthesis plus ab. We haven't dealt with operators yet. And I think my understanding is Swift, Elm took away the ability to define your own operators, so we don't have to worry about new ones other than the ones we have here, I guess. All right. Cool. So I don't know if I checked that last bit in. No. Great. So support tuple product types and make tuple return them properly. Okay, that's this. That is good. I'm very happy to have that worked out. See, what I wanted to do was be able to say, well, the expression I want to be able to type is like this. I want to say parenthesize lambda n goes to n, well, even if I can just do this of 3, I want to make my function calls start working. But if I just had it without the parentheses, I don't think it's a legitimate, it's certainly confusing, even if it is legitimate. But this, I can say, okay, I've got a function of one argument returning itself, pass in 3, and that should come back with, 3 of number. Okay. We don't do function calls yet, though, so that's probably a decent thing to look at. I don't know. We may need more mechanism, but just having the lambdas and not supporting the argument types, the arguments they get complicated. Yeah, we have to be prepared for simple arguments, array, tuples. What do they call these other ones? Records? Yeah, records. Our functions can take all kinds of things, so that's a little funny. Okay, so we're at one of these points. I don't know. I'm just kind of like, what's next? I think because I've resisted it so much, I think I want to get back to the REPL and the UI, because I would love to be able to play around with these expressions we've got so far and test what's the type of a nested tuple, what's the type of a this with a that or something. I don't know. But I don't understand what that number 1 means. I guess it's that, they're generic types, so this is one type and this is another type. There's nothing that ties them together until you combine them somehow. I guess it's saying, well, it would be more, let's see. What if I do like true, false? Really? Oh, capitals. Boolean. It knows the concrete type. I don't know. I'm trying to get a reason why that thing needs to be generic across two separate things. I guess in the end we could do something that was an int and a float, and we don't want to constrain both of them to be floats. That's probably what it is. Okay. We don't handle that number 1 yet. That's something else is going on there. And maybe the tuples need a wrapper, or they're generic around that or something. I don't know. We definitely don't handle generic types very well. All right, but anyway, back to this. I think I want to get the REPL next, and we're getting stuff in there, and there's enough to play with. It's a touch boring, but once you have function definitions and function calls, you sort of have the whole language, right? So I guess like if you have infinite precision arithmetic, you can probably have enough to do a Turing machine complete thing. Okay. REPL in UI. So automatically scroll. Let's run this thing. We haven't done that today. Takes a moment. Okay. So the way this is this is our log and this is our active stuff. There's stuff going on in here, but if I do true and evaluate, okay, it comes back that. Okay, so we got it hooked up a little bit. If I do parenthesis 3, how about parenthesis 1, parenthesis 2, comma 3? I wish you could hit return. Oh, something's funny. All right, let's see what we got it hooked up to, because I don't remember. All right, I'm going to close others. User interface, content view, and interpret view model. All right, so I guess the view model is the interesting thing. So, we are doing evaluates. Okay, so yeah, first thing we play with, I find an error, right? So evaluate. So really, right now there's the session string and the input string. The input string is the box we're typing in. The session string should be an output only display, and there's a button action evaluate. So it appends the input, it evaluates the input, and then it clears out the input. Oh, appends a new line, clears out the input. So we are calling our interpreter. Now, okay, so that makes me a little worried here. Internal error should not happen, really should not happen. So what's going on there? Let's go back to our tuple tests. Those, well, maybe parser tests. Okay. Let's test nested tuples. Our input should be 1, 2, 3. Properly nested. Our output, I'm going to say, I don't know. So we're using this in experimental mode. Expected pipe. Well, no, let's do error. Empty expression. We'll get some use out of it, I guess. All right. What I really expect is a tuple expression with the first argument an integer, the second argument a tuple expression. Tuple 1 with a number, with tuple 2 and 3 with numbers. Huh. Oh, we don't know how to print that, I bet. Evaluate. Yeah, we don't know how to evaluate that thing at all. Okay, so we did the lexing and we did the parsing, but we didn't do the evaluation. Okay. That's not a parser issue then, so let's cut this out of here. It's really an evaluation issue around how do you evaluate a tuple. Okay. So, we don't need that. I guess we really need, well, I didn't need much of anything there. Tuple consisting of integer value 3 comma elm type dot number and second argument of the array, second value of the array is it's another tuple. Well, let me do my example from before, just 1, 2, 3. Okay, which has stuff and it has a type. And then outside this one, we have another type, which is the tuple type. Elm type dot tuple with elm type dot number and elm type dot tuple. So the type of the tuple is going to be number plus the type of the inner tuple, which is another array, elm type dot number and elm type dot number. Okay, I'm getting lost in my stuff, but this tuple should have this inner type. And the type, this thing here, let's get some nesting visible. Okay, that bracket ends here. And then the overall type. Okay, so integer value, the tuple, tuple of, well, we need 2 and 3. Elm type dot number, elm type dot number. Okay, so the inner tuple I guess that's right. All right. Inner tuple. Okay, there's the outer one. Here's the first number. Here's the second one, elm type number. That's right. Integer value 1 with tuple with 2 and 3, which has type number. Okay, something. Okay, we'll let value equal that. Okay. Yikes. All right. But when you evaluate it, and I don't know, we must have examples of evaluating. Parser variable tests will be interesting. Okay. Value, evaluate. So we're going to evaluate the expression with a symbol table. We don't need any values in it. And we expect something back. Okay. Symbol table is an empty symbol table. And then we're going to do let result equal value. Well, how actual is going to be value dot evaluate with the symbol table. Okay. And we're trying to find out what that is. What do we expect to come back? Well, we expect crazy enough. Well, we actually expect the table we have. Let's assert equal. Actual should be value. Now, I don't know if that's obvious. I guess it's not obvious because even when I'm claiming it, I'm not claiming it's obvious to me. But I think what's going on is if you've got a tuple of all constants and there's no expressions to evaluate, then the value is the same thing. So when we evaluate integer value, we'll get that value back. When we evaluate the tuple, we'll get the values inside. So I think I think that's right. I don't know if it will. I guess I don't think it will pass because we don't have an evaluate on our tuple. Whoops. We don't have an evaluate on our tuple. Okay, so yeah. Okay, so that does not pass. We expect tuple 1 with tuple 2 and 3. That is the result of evaluating that. Okay, so, okay, it's just the parent. Let's get into tuple. I don't know what the, yeah, do I have this? Cool. Right, he has no evaluate. We'll just take a peek at variable, function evaluate, and I'll just borrow this. Tuple evaluate. Okay, expression. We don't care about that stuff actually. Return. Well, yeah. So what we have to do. I think we can say the result of evaluating a tuple is another tuple. So if we had parentheses, let's do it in the REPL. I think if we do this, 1 plus 2, 3 plus 4, we should get 3, 7. Yeah. Of the tuple type. Okay. So we're at a failing test. Let's see if we can quickly do it. So I think what we're going to do is we're going to take values dot map, and we're going to take each value that comes out, each expression, and evaluate it in the context, which is our symbol table. So just like here for variable, we evaluate the expression with the context. I don't know. We don't need to worry about the name, but we're expression.evaluate context. I think that we're going to take all those and that gives us an array of values, and we're going to pop those in a tuple. And that's the only thing we're doing. So we're going to take tuple with values.map, and we got the type already. So I think that may be it. I find myself rushing because I've got 2 minutes left, and I want to know if we're going to get it right in one shot. Yeah, okay, and let's run it in our real environment. All right, and so did that build? Okay, it built so fast I didn't know what to expect. All right, so 1, 2, 3, evaluate, and then 1, 2, 3 for contrast, evaluate. So we got a spacing issue still, but this one is a nested tuple, this one is a flat tuple, and that's the way it goes. That's what it should be. All right, so what we've done, we got the parsing done. The parsing produces a tuple consisting of expressions. The expressions could be arbitrary things that need to be evaluated. When you call evaluate, it takes the symbol table and that tree of expressions, evaluates each expression, and then rebuilds it back into a tuple that's a result. So operating on tuples produces tuples by default, and that's kind of what we demonstrated here. And we have the types right-ish. See, our output is not really the same as theirs, so we got a little bit of work to do there. But we'll pick that up next time, which is tomorrow morning, 9 to 11:30 Eastern time. And I'll look forward to seeing you then or in some other time in the future. But thanks for joining me. Bye-bye.